Welcome back to Future Data Scientist. We cover all the steps in the data science pipeline: problem identification, data collection, data cleaning, exploratory data analysis, feature engineering. Now it's time to for the most exciting part. It's step 5 is model building in machine learning. In this video we learn what is model building, different types of models, how model learn from data, how we evaluate the improved models. Let's get started. So, what exactly is model building? Well, it's the process of teaching machines how to learn from data and make predictions. Think of it as a training or digital brain. We feed in historical data, train the model, and test how well it performs, just like human learn from past experience, machine to do. Then, question arises: why do we need it to classify emails as spam versus not spam? To predict future sales revenue for a company, to recommended movie on Netflix using AI. There are three primary types of models. First is classification model, regression model, and third is the deep learning. Let describe the classification model. Classification model is used for categorical prediction. For example, like spam versus not spam detection. Regression model is used for uh, numerical prediction. Example like predicting monthly revenue. And third is deep learning. Advanced AI models like neural networks. Example is the Netflix recommendation system. We see the different models, but not all models are the same. Different problem requires different approaches. Let's break it down. First is classification model. When we need to categorize data, where we use classification model. For example, like predicting if an email is spam or not. In this case, we use the machine learning models like logistic regression, decision tree, and random forest, and SVM like support vector machines. Then second is the regression. Regression is the when we need to predict continuous value. We use the regression models in ML like linear regression, polynomial regression, and lasso regression. Example is forecasting next month sales revenue. Third is deep learning. Deep learning is the when we need complex pattern recognition. We use deep learning models. Example is Netflix AI recommendation movie based on view the history. Last view history. We use ML models is neural network, CNN for image recognition like. Alright, we have chosen a model. Now it's time to train it. Training means feeding the model with data so it can learn patterns and make accurate predictions. But now, how does it actually learn? It's break it down. That break it in training data, the historical data we provide to train the model. Then second is loss function, the model ways to measuring mistakes. Then third is optimization algorithm. It helps the model improve like gradient descent and Adam optimizer. Then fourth is the Okobus iteration. It is the number of times the model learns from the data. Now that's we have built our machine learning model. How do we know if it's actually good or not? That's where model evaluation comes in the picture. Today we will explore different ways to measure model performance and when to use each matrices. First is accuracy. Accuracy is the overall score. Accuracy is the simplest way to evaluate a model to tell us the percentage of correct prediction out of the predictions. Formula of accuracy is accuracy equals to correct prediction upon total prediction into 100. Accuracy works well when classes are balanced, but if a dataset is highly imbalanced, then example of detecting rare disease, a model predicting no disease is 99% of the time might still have high accuracy, but it will be useless. The second is the precision and recall. It is the handling imbalanced data. In precision, how precise are the positive? Precise is the formula R. Precise equals to true positive upon true positive plus false positive. Example of this is if a disease detection model predicts 100 patients as sick, but only 8 of them actually have the disease, the precision is 80%. High precision means fewer false alarms. Recall. Recall how many actual positive were caught. Recall formula is recall equals to true positive upon true positive plus negative. Example of that is out of 20 actual sick patients, the model accurately detects 60. That's an 60% recall. High recall means fewer missed cases. Positive versus recall trade-off is increasing precision may reduce recall and vice versa. If you want to catch very fraud case, it is highly recall. You might end up with more false positive. If you want fewer false alarms, that is high precision. You might miss real fraud cases. Third is the confusion matrix, a detailed view. Confusion matrix is the predicted positive, predicted negative versus actual positive and actual negative. A confusion matrix helps us analyze a model performs beyond just accuracy. It's break it down with an example. True positive. True positive is the correctly predicted positive value. True negative is the correctly predicted negative value. False positive is the incorrectly classified negatives. False negative is the mispositive. Then fourth is the F1 square, the best of both worlds. F1 square equals to formula is the F1 square equals to 2 into precision into recall upon precision plus recall. The F1 square is the harmonic mean of precision and recall. It balances both, making it its great matrix when classes are imbalanced. 5 is the ROC and AOC. It is used for measuring model confidence. ROC and OEC is full when we need to compare different model. It higher the IOC, the different better model is distance between classes. And 6 is the measure squared error. It is used for regression model performance. MSE measure how far off our prediction are from actual value. A lower MSE means a more accurate models. Choosing the right matrix is used for the good model, and that's how we evaluate machine learning model. Choosing the right matrix depends on your problem: accuracy for balanced data, precision for recall, and imbalanced data, confusion matrix for classification, and MSE for regression. Let's see the one example. Netflix does not just randomly suggest movies. It's powered by AI and machine learning. Let's dive into the fascinating technology behind the Netflix recommendation system and how it's personalized your experience. Imagine two Netflix users, Alex and Sam. Alex loves thrillers and science fiction movies, while Sam enjoys thrillers and horror. Since they both like thrillers, Netflix might recommend horror movies Alex and a science fiction movies to Sam. This collaborative filtering. How it's work? Netflix groups user with similar tastes. It analyzes what people with similar preference have watched. It suggests movie based on patterns across different users. Limitation in that is collaborative filtering struggles with new users who haven't watched anything yet. This is called as cold start problem. Then second is content based filtering, understanding your preference. How it's work? While collaborative filtering recommends based on similar users, content based filtering focus on the movies themselves. Then its work as the model in each movie is labeled with genre, themes, actors, and keywords. The AI learns your preferences based on you watch. What you watch? The recommendation movies with similar characteristics. Then third is the deep learning model predicting what you will love. Netflix takes recommendation a step further using deep learning. These AI models analyze massive amount of data to predict what you will love. Then how it works in the backend. Neural network analyze what history, pause point, and replays. AI consider theme of day, device use, and watching behavior to refine suggestion. The model continuously learns from user interaction. Hybrid approach is also using that, the best of both worlds. Netflix does not just rely on the one method, it combines collaborative filtering, content-based filtering, and deep learning to make recommendation even smarter. Why hybrid model works best? Solve the cold start problem to new users. Provide diverse recommendation, not just similar content. Adapts to user preferences in real time. Netflix AI goes beyond what you watch. It also considers general probability, trending movies and shows worldwide, watch duration. Did you finish the movie and stop halfway? Use feedback, thumbs up, down, up, ratings and reviews. Seasonal trends, holiday, theme, recommendation during December. All these factors help Netflix fine tune your recommendation. As AI technology evolves, Netflix recommendation will get even better. With advancement in reinforcement learning and personalized storytelling, we might soon see AI generated thrillers and fully interactive viewing comparison experience. Comment below what the best recommendation Netflix has given you. Like and subscribe and more insights. Last topic of the model building is hyperparameter tuning. What is hyperparameter tuning? Is nothing but improving model accuracy. Improving accuracy is the one to boost your model's performance. Try hypermeter tuning. This process fine tunes model setting for better accuracy. They are used the grid search CV to test as multiple parameter combination. Then randomized search CV. They are used for faster alternative for large dataset. Then third uses regularization. Regularization used for prevent overfitting. And what's wrap on model building? We tried model, evaluate them, and even optimize them for better performance machine learning. In the heart of AI, Netflix, YouTube, and even self-driving cars use also. Then this is the conclusion of model building video.